Hi, I'm Curt Frye. In this movie, I would like to continue my look at the traveling salesman problem by moving from one driver with the most efficient route to two drivers and finding the most efficient route if we need to split the load. If you want to follow along, you can find the sample file I'm using at tsp_equal using the download link that I provide in the video description below. In this workbook, I have a set of stations numbered 1 through 14. The drivers are both going to start at station 1, and then they are each going to visit 7 other stations and return to station 1. The distance matrix, which tells you how far it is between any pair of stations, is here on the right. So if you look at the row first, going from station 2 to station 1, it's 21 miles, and it would be the same if you were going from 1 to 2. And we're assuming that everything is symmetric. And if I scroll down, instead of a single path, I have 2 paths. So I have stop 0, which is where they begin. Then we have 1, 2, 3, 4, 5, 6, 7. And then I've labeled stop 8 as the same station as the starting point. And I calculate the distances over here on the right, distance 1 and distance 2, total them up, and take that total and have that as the value we want to minimize. I have the stations in numerical order, so the route map shows 2 routes that are very long and definitely not efficient. And if I scroll down, you can see that I'm using lookups to take a look and calculate the distances and also the points that will be put into the map. So I will scroll up and then go to the Data tab of the menu and then click Solver. And that displays the Solver Parameters dialog box where I can start to create my solution. The objective cell is here at cell E30, so I'll click that. I want to minimize the total distance traveled, and the variable cells, I'll click there, and that's everything I have highlighted in yellow. And those are B20 through C26. The solving method is already set to evolutionary, which we need to use because this problem is not nonlinear and very definitely is not linear. The other option that I need to set, so I'll go to Options and then go to the Evolutionary tab of that dialog box, is to require bounds on variables. So with that in mind, I will click OK and add 3 constraints. So click Add, and the cells from B20 through C26 must all be less than or equal to 15. That is the maximum or highest station number. I'll click Add. Then the same cells, which I'll select again, must be greater than or equal to, misclick there, greater than or equal to 2. Click Add. And they must all be different. So cells again, B20 through C26, they must all be different. And I'll click OK. So there is the model, and I'll let you know right now that we are going to get an error. I'll explain why that happens and what we can do about it. So I'll click Solve. There is our error message, and the message, which is here by the exclamation point, says variable bounds conflict in binary or all different constraint. And all different constraint must either have no bounds or a lower bound of 1 and an upper bound of n, where n is the number of cells in the constraint. Okay. I want to have boundaries so that I can specify the values will go from 2 to 15, or in this case, we'll have them go to 1 and 14. So let me show you why that works as a solution. I'll click Cancel. So we're back to our original values. And what I can do is to change the positions of station 1 and station 15. That way, I can have the drivers start at station 15 and visit 1 through 14. So I have 16 and 2 and 13 and 17. So I'll type 13 and 17 here. And then I'll do 16 and 2 here. And I'm just doing this to make sure that I don't make any errors. Yes, there are faster ways to do it, but the way that I did it, make sure that everything goes in correctly. Next, I need to have them start and end at station 15. So in cell B19, I'll start route 1 at 15. Then C19, that'll be 15 as well. And then we'll go to the end of each route, and those will end at 15 as well. So there we have our solution, or excuse me, there we have our problem set up. And I will go up to solver, and I need to change these two constraints. So instead of going from 2 to 15, we need to go from 2 to 14. So I will click what is for me the top constraint, less than or equal to 15, change. Same cells, we just go from 14, click OK. Then greater than or equal to 2 needs to become greater than or equal to 1. Click OK. They are all still all different. So I will click Solve and come back when Solver has found a solution. Okay, the Solver has found a solution, and just looking at the map in the background, it seems like it's probably pretty good. So I will click OK and scroll down to take a look at the route map. And yeah, this looks like a great solution. We have 2 routes, which is what we required, and they are both simple looking with no crossings, and the values are 61 miles and 113 miles, and that's not surprising because we have these long distances here at the top. So that tells me that we have very likely found an optimal or very close to optimal solution. For comparison purposes, let's see what the optimal solution would look like for one driver, and that is on the one driver worksheet. And if I scroll down to take a look at the route map, this is the route that a single driver would take. And what's happening, if I switch back, is that instead of going from this point to this point, instead, for 2 drivers, they're both starting from here. However, for the single driver, they don't go back to here and then go here. Instead, they will just continue on straight and, in fact, save a little bit of time and distance in doing so. I won't go into the full details of what you need for a 3-driver solution, but I have created it here on the 3 equal worksheet. And here, instead of having 2 routes, I have 3. And I also have 15 points, so it's all equal. And they start at point number 16 and end at point number 16. And I calculate the distances exactly the same way that I did before. I just add a 3rd column for the 3rd driver. And then here at the bottom, I have the map. So I have route 1, X and Y, same for route 2, same for route 3, and that creates the route map. So again, I have added distance columns so that I can find the total of all the distances traveled. Then I use the points from the solution here to look up the X and Y coordinates for each point on the map. And when I created the map, I used a different series to map route 1, route 2, and route 3. And that's the solution you see here on the right. So have fun playing with all the solutions here, but the one you should focus on to make sure that you get the process exactly right is 2 equal. And remember, you have to start using the technique that we use, your variable cells, all different cells, at 1, but you can go from 1 to 14 and have them start at position 15, and it doesn't make any difference whatsoever to the solution. Okay, that's a lot of detail. I hope you enjoyed it, and you can use these insights in your own work. If you enjoyed the video, please like it and subscribe to my channel.